Hello everyone. Last time I finished the construction work by pouring a monolithic reinforced concrete outline, and it's just an outline, not a full-fledged reinforced belt. It was poured along two walls to create a reliable base for supporting the floor beams. For the floor beams, I bought laminated veneer lumber beams. Simply put, it's plywood of a large cross-section, which allows you to span large distances up to 13 meters. In my case, I needed to span a distance of 7 meters. According to the calculations from the Ultralam online calculator, the required beam cross-section was 90 by 240 millimeters. The length of each beam was 7.3 meters, and the approximate spacing needed to be 600 millimeters. My future flooring must meet all the requirements. With a load of up to 300 kilograms per square meter for a full-fledged second floor, and let's say with a floor screed, the calculated load should be higher. And then you either need to increase the beam cross-section or decrease the spacing. But I'll have an attic floor where in fact the load isn't even expected to reach 200 kilograms per square meter. Before starting the installation of the beams, I thought it would be reasonable to prepare the seating areas in advance. So I began by preparing the surface for laying the aerated concrete block above one of the openings. I had a ready-made aerated concrete lintel, and it was sticking out a bit, so I used a float to level the wall surface. Next, I cut pieces of aerated concrete blocks, 100 millimeters thick, to cover the ends of the beams and the floor slab. I used wall blocks to fill gaps between beams. Since the aerated concrete blocks followed the reinforced concrete contour, I needed masonry adhesive. Actually, I did almost all the masonry of the exterior walls of my house using foam, and I was able to appreciate all its advantages. But for laying aerated concrete blocks with foam, you need a perfectly flat surface. And no matter how much I wanted to, it was impossible to lay the blocks with foam on the monolithic concrete, so I had to climb around the walls with a bucket of adhesive in one spot. My monolithic outline extended beyond the edge of the block, and I had to improvise with an axe to make the surface more even. This time I figured out to buy a mixer to make mixing easier, because before I just mixed everything with a shovel and a screwdriver. Mixing the adhesive for the aerated concrete block didn't work, so I used a rotary hammer. Since the mixer can't be directly inserted, I also had to buy an adapter with a clamping chuck. Mixing the adhesive this way is much easier than using a shovel. Mechanizing labor on construction sites saves energy and time. Over the winter, I got a bit out of practice working with my hands, and at first the masonry was crooked and very slow, but then I got the hang of it. After forming the ledge at the installation point, I practiced fitting the lids, and after shaping the ledge with a file, I trimmed the handle strip a bit. What's important is that the height of the blocks for the lid, the shape. I had to cut the fuel chain out of epoxy, and as far as I understand, when laying walls from aerated concrete blocks, there's no need to wrap the entire beam with insulation, just using pads is enough. I put 3 pads under each beam. First, in the hope that this would somehow improve the floor in terms of vibration and impact noise transmission, and second, it added, even if less than a centimeter, still a bit to the ceiling height. And third, by adding or removing a pad, I was able to level the floor beams almost perfectly. The exact weight of one beam is unknown, but it's around 100 plus kilograms. I called a friend to help so placing the beams together would be easier. With 2 people it was actually pretty easy. I deliberately didn't place the edge beams right up against the wall, but left a larger gap so that it would be easier to insulate that area later. When half of the beams were in place, it freed up space to lay blocks for the other beams, and so I gradually set all the beams by myself. It's possible to set them up alone, it just takes much more time, and with a second person productivity increases several times over for this kind of task. But I didn't want to keep bothering my friends, so I managed on my own and saw for myself in practice. Why should you stop laying aerated concrete blocks? In the rain? I'm not made of sugar, I won't melt, I thought, and went to work in the rain. When you apply the adhesive to the block and turn away to set down the spatula and trowel, the block is already in the adhesive. Water has already dripped in, it became too runny and just flows down the wall, and it's physically impossible to do the masonry. Foam, in this regard, again, has a slight advantage over adhesive and allows you to lay blocks in our favorite St. Petersburg weather, +1 and rain. The length of the laminated veneer lumber beam was supposed to be 7.3 meters, but either they came longer than they should have, or maybe something else. The tape measure I used and the one at the beam factory were different, so I had to saw off the end of each beam. I just cut them on site with a regular handsaw. While the saw was new, fresh from the store, the beams were easy to cut. I didn't bother bringing the circular saw upstairs, simply because during the days I was installing the beams, the weather was very unpredictable and it looked like it was going to rain all the time. As you can see, the spacing of the beams turned out a bit odd. This is due to the spacing of the rafters, and the spacing of the rafters is determined by the fact that there will be skylights, which require a rafter spacing of about 90 centimeters. Plus, the future staircase to the attic will fit perfectly into one of these spans. There shouldn't be any problems with installing the insulation, because I plan to use roll wool that's 1.2 meters wide, and it can be easily cut to the size I need. I was considering above rafter insulation with polyisocyanurate, but it's 3 times more expensive, so for now those dreams will have to stay dreams. Actually, I'm ending up with a rather strange house with some questionable decisions and a few mistakes, all because I started out building a single-story house. And the attic is more of an artistic improvisation that appeared along the way. Plus, I didn't have a proper design from the start either. I cobbled together something of my own from 3 ready-made projects. Ideally, I should have either stuck to the original plan or included the attic at the design stage. So, if you want to build your own house, at the very least, train your eye by looking at different house designs. In order to carry out all the subsequent work and to make it easier to get upstairs, I needed a temporary staircase. As you know, nothing is more permanent than something temporary, so even for the temporary staircase, I wanted to make it comfortable and reliable. I used 2 boards, 50 by 150 millimeters as the base, and cut their edges at a 45-degree angle. Using a square, I marked where the future steps would be placed. The height from step to step turned out to be 22 centimeters, and the width of each step was also about 20 centimeters. As supports for the steps, I used a bar measuring 30 by 40 millimeters. Not on purpose, it just happened to be the size I had lying around. For convenience, I first fastened the bars with screws, and for reliability, I nailed everything down. Since cutting up new, good boards for a temporary staircase is quite an expensive pleasure, I made the steps for the staircase using whatever materials I had on hand. In the end, I realized that I shouldn't have cut these spots at a 45-degree angle, but rather left them to support the steps, since I wasn't aiming for beauty here. I also nailed a few crossbars to make the staircase sway less from side to side, but overall, it turned out to be a pretty convenient staircase that you could carry blocks up without being afraid of falling. To complete the stage of working with the floor beams, I needed to make crosspieces between the beams and connect them into a single solid structure. For the crosspieces, I used the same 50 by 150 mm boards, measured the distance between the beams, and immediately cut all the necessary crosspieces. Since I have no experience with this kind of work, and in general, most of the tasks in building my own house I'm doing for the first time in my life, I really struggled with the crosspieces. At first, I tried to do everything from above, but it turned out to be quite dangerous and inconvenient. It was much easier to work from below and from a ladder. The question of how to fasten the crosspieces between the beams also made me think. I decided to try three options: screwing in thick 130 mm screws at the ends, nailing the beams with 150 mm nails, or attaching the crosspieces with brackets using small screws, and screwing in the 130 mm screws. It turned out to be very difficult even with a hammer drill, and drilling all the holes took a very long time. Plus, screws don't handle dynamic loads well, and there's a risk they might break. The nuances of attaching with brackets make it very expensive because of the price of the brackets. As a result, nails turned out to be the cheapest and most convenient method. The only nuance is that, since I have golden hands, and driving a nail through 9 centimeters of plywood isn't easy, some nails bent and I had to pull some out, while others I straightened on the spot and managed to hammer in. In the end, attaching the crossbars turned out to be a mixed bag. In some places I used screws, in others nails, and in some places brackets, with the crossbars. I also had to use the phone a friend option because it's much easier to attach the crossbars when someone is holding them. When it came to marking for the crossbars, I made the job a bit easier by only marking the outer beams, and then together we just stretched the string from them. We loosely attached the crossbars to hold them in place, then I went around and secured them properly myself. Everything is known by comparison, and I remembered that another friend has a garage with a span similar to mine, covered with a regular 8-meter beam, and I became curious about how a regular beam behaves compared to laminated veneer lumber. Today I'm at my friend's garage because at my own house I'm making floors using laminated veneer lumber beams, and I became curious whether it's worth overpaying for them, because they cost a fortune, and there's also regular beams. And for example, my friend has a garage where the span is 7 meters just like in my house, and it's covered with regular beams, installed with a large spacing. The beams here are planed, and originally they were about 150 by 180. Now it's a bit smaller, about 145 by 175 because it was planned. The distance between the beams is 1 meter. The beams were ordered to be 8 meters long cut at the sawmill, so the length is 8 meters. And here you can see that the edge of the rafter goes out, so the beam extends beyond the wall, and the edge of the rafter rests on the edge of the beam, resulting in a thrustless roof. And it turns out that if you want a garage, there's no other way to do it. Because you can't put a load-bearing partition in your garage, you need a large span for a big garage. If you need to create storage space in the garage, then this type of rafter system is an excellent solution. When the rafters rest on the edge of the beam, you end up with free space here. Here, we got a space like this. If, for example, you use a truss, you won't have this, and with trusses, it's quite easy to span a large distance without sagging or anything like that. But you won't have a space like this under the roof, because it's a great place to store all sorts of stuff that accumulates over the years. Now let's do a standard test with a glass somewhere in the middle. How does this kind of floor behave? Basically, you should already be able to tell from the wardrobe that this is like a trampoline. So basically everything falls off the wardrobe, but the water, well, the water is fine, it behaves normally. Things fell off the wardrobe, but the water is fine. It's much better than what I had in my little house. Books are falling off the wardrobe. Books fell off the wardrobe. You can feel the floor bounce under your feet. So basically it's a viable solution, let's say, for a garage or a summer house for temporary living. Of course it would be uncomfortable to use it as a living room. It will be very interesting to compare this with my floor made of laminated veneer lumber beams with a larger cross-section and smaller spacing, and see how it performs and whether it really makes sense to pay extra for laminated veneer lumber. I think it's too early to draw any solid conclusions about my beam flooring, because there's no floor covering yet, and for now these are still separate beams, not a solid structure. When the floor covering is installed, I'll immediately record a video about whether it was worth it. And speaking of money, 11 laminated veneer lumber beams for the flooring cost me 73,000 rubles. The fasteners were another 1,000, the boards cost 3,000, and the labor took 40 man-hours. In total, as of today, I've already spent 1,110,000. But that's taking into account that most of the roofing materials have already been purchased. Next, I still have a bit of masonry work, the reinforced belt, and the roof itself is not far off, which I'll talk about in the next video. So subscribe to the channel so you don't miss out. If you have any questions, feel free to leave a comment. Live long and prosper.